I'm calling this heat transfer on Earth. Let's do it. So, basic one, sun giving energy to the Earth. Sunlight is called insolation. As a matter of fact, I want to draw it more like this because it's just radiation. So I like to show the waves there to make it look a little more understandable. And this is called insulation with an O, not insulation with a U is the pink stuff that's in the walls and your attic and stuff. But insolation is sunlight. Now, it's short for incoming solar radiation. That's where it comes from. So know that. Insolation. The word comes up a lot. It means sunlight. So here's just a quick thing on that. Which will reflect the most insolation? Okay, so there's two things that matter here, color and texture. The answer here is going to be A, because it's light color and smooth texture. Smooth surfaces reflect more and absorb less. So the next question is, of these same materials, which will absorb the most insolation? And you probably know that dark colors are going to absorb more sunlight, but it's also the rough texture. Dark color, rough texture are necessary for absorbing more radiation, in this case insolation, meaning sunlight. Know it. And here's the question for an example. Equal areas of which surface would absorb the greatest amount of insolation on a sunny day? Keyword being absorb. Therefore, we're looking at dark colored rough surface. Okay? This is another regions question, and it shows sunlight coming in and it's showing the amount being reflected. You see the arrow coming off. So, and our materials are sand, a grassy field, fresh snow, and a forest. Well, which is reflecting the most? Fresh snow, pretty smooth surface and really white, so it reflects a lot, and it has percentages here. Which will absorb the most and therefore reflect the least is the forest. Think of a forest being dark color, really rough texture if you think of the tops of the trees. So that's a good example from a Regents exam. That diagram is used. So this is getting a little more complicated. So basically the sun, the energy from the sun is this short wave, if you could see the waves. Not to scale, by the way, but this short wave radiation, it gets absorbed by the Earth, and then the Earth gives off this longer wave radiation. Air doesn't really absorb a lot of sunlight by the nature of its wavelength of the sunlight. Air is not a good absorber of sunlight, but Earth gets warmed and it gives off this, which is infrared radiation, okay, which we're going to get to and how that warms Earth. Check this out. So infrared, we see infrared. This is on page 14 of the reference table. That's where you see infrared, though this diagram usually does not help you answer the questions where I'm going with this, which is global warming. So here's another example from the Regents exam. It shows visible light coming in a window. It heats up the table, and the table gives off infrared radiation in this case. So here is this stuff comes up a lot. Most of the long wave energy radiated from Earth and lost to space on a cloudless night is infrared. Infrared, okay, that's what Earth gives off. Now, this is the greenhouse effect. I am sure you've heard of the greenhouse effect at some point. Now, this is how it gets its name. Okay, so a greenhouse works like this. If you know a greenhouse, it is basically a glass building where you grow plants. This helps it be warm so you can grow plants in the cooler weather. So solar radiation comes in. Notice it's shorter wavelength. It heats the ground and the plants in, or anything that's inside the greenhouse. And that stuff all gives off radiation, which is infrared, longer wavelength. And the idea here is that this type of radiation goes through the glass, but this cannot go through the glass, okay? And that causes the air inside the greenhouse to warm. Now, in our environment, the greenhouse effect, when we talk about our climate, is it's not glass that keeps this energy in. It is greenhouse gases will absorb this infrared radiation. Okay, and the greenhouse gases these are the three main ones that you need to know: carbon dioxide, CO2, methane, CH4, and water vapor. Know those, it's important, okay? And this is a big issue in the future, so everyone really wants you and your generation to know this. So basically it goes like this. These three greenhouse gases are increased by burning fossil fuels and deforestation, or at least definitely carbon dioxide is increased by burning fossil fuels and deforestation. And this causes climate change, which is warming, because if we go back here, what's absorbing this are the greenhouse gases. You have more greenhouse gases in the atmosphere. There's more absorption, hence warming. So this is all important to know and understand because there's a lot of different types of questions that involve you understanding them all to get them right. So here's an example of one. In addition to carbon dioxide, 2 other major greenhouse gases in Earth's atmosphere are water vapor and methane. That's an example of one. Here's an example of another one. It says identify one major greenhouse gas other than carbon dioxide. I think for so long, kids just knew carbon dioxide, but they didn't know any other one. So they do stuff like this. So make sure you know those 3 because I've seen questions that even ask for all 3 in multiple choice. So know them. And just to review, they are this: carbon dioxide, methane, and water vapor are the greenhouse gases.